Welcome to another Soil Revolution update, where we talk everything regenerative agriculture. In tonight's presentation, I engage with advocates from the iCow Soil Advocates Program, together with iCow CEO Sue Kahombo. We take a look at how to optimize the utilization of microbes through activated aerated compost teas. This is especially very promising since it helps us to very efficiently stretch little resources to go a long way, making it economically sound, sustainable, and scalable. I hope you find it exciting and captivating. If you haven't already, please subscribe to our YouTube channel, share this video, and let us engage in the comments section. Welcome.
We missed the forum for last month. We were planning to do the Billion Agave program, and we were planning to lead that. But when I reached out to that team in Mexico, they offered to do the presentation themselves, but the time was short. So then I said, okay, let's look at what else we can do now as we're heading into a time that we've got actions that are happening by some of us of advocates that are really interesting and we're following in our chat groups. What can we do to bring that to a larger audience? And that's where I thought, why don't we look at the activated teas? When we all came in for our meet in Ilri, we all went home with earthworms. And again, I saw Abdi Omar has put pictures of his earthworms on the chat. But we also know that the leader in this space and the person who won the trophy for earthworms is Paul Muigai, and he has learned to use earthworms beyond what most of us actually even can envision. He has learned how to seriously, through some of his learning with us and some of his learning online, to optimize the use of earthworms and the microbes and the nutrient recycling that is done to nutrient cycling to a degree that honestly non-comparable cost for cost. So we thought, well, let's bring Paul in, and we've watched Paul go from he's a tinkerer, go from making the machinery really Juakali style and making tools and sharing tools with us, zooming ahead to producing a few liters of what he will show us, to now going into a semi-commercial scale, I would say almost, which is quite amazing. So today's session, Paul will take us through that. And then Kate and I will go back to where showing you how you can do this without all the equipment that Paul has. But there is a twist that we found out at the end that actually complicates things a little bit, but not too much. So without further ado, that's where we came from. That's where we are. Paul, over to you. And thank you for coming and doing a presentation today with us.
Well, thank you very much, Sue, for all those accolades. I am really humbled. Yeah, it's been a journey for me, a great one. And I'm quite pleased to be part of this team and to journey together. So, well, without further ado, let's get into the presentation. All right. So, I don't know whether we can see that. Activated.
Yes, it is okay.
It's okay. Yeah, so my name is Paul Dongo Muigai. I am a farmer and a soil advocate based in Trans Nzoia, Kitale. We do a lot of maize farming in this region and a few other vegetables, but mostly the area is predominantly maize and now starting to go into sugarcane. Now, a little bit of background. I grew up in a farming family. Always done it conventionally. We used relying on tillage, the use of fertilizers and chemicals, and we didn't know any other way. So when I first heard about no-till farming, that was about 6 years ago. A friend of mine, we were just having a chat at the farm and happened to mention about this system with no-till, and I really got fascinated. So that night when I went to bed, I went on YouTube and I decided to search, and I came across this presentation by Dr. Alain Ingham. The title for the video is The Roots of Your Profit. And when I watched that video, I was really captivated. That really got me thinking about all the possibilities. I hardly got any sleep that night. I went on a watching spree up to around 2 a.m. And I was so excited that the following day I woke up and decided to pay a visit to the Ministry of Agriculture here in Kitale. I was hoping that I'd be able to get some information on the same, but unfortunately, there was none. Whatever the gentleman that was there told me was what I needed to do was to substitute our plowing implement to get a chisel plow instead of doing it with a disc plow. As much as I didn't know so much,
Sorry, Paul. Sorry for that. James, please manage microphones. Thank you.
Yes, as much as I didn't have a lot of information myself, I felt like no, that can't be it because of what I just come from watching the previous night. So I started actually on a very lonely journey of trying things without really knowing where this is heading. Or so the first few years were quite not so rosy, though quite rough. And I was having this moral dilemma. I don't know, should I give up on this thing? Or because it simply was not working. I would see all these other YouTubers and online farmers in Europe, in America, doing this thing, and it's working for them. And I'm wondering, why can't I get this thing right? And I think a couple of years into it, I almost gave up. Actually, it took me another 2 years to get back to the farm. But from that experience, I had learned something. I had learned that, one, our soils were in really bad shape, really sick, if not outright dead. And I also learned that whatever we called compost, or compost is not just compost. We need to be really keen about how we do our compost. It needs to be aerobic and it needs to be biocomplete. And of course, last year in June, I was lucky also enough to have joined the iCow soil advocacy program. And I felt like, wow, finally, a community where we can belong, because it seemed like I was talking strange things to people and trying all these things, and no one understanding what I'm trying to do, and no one understanding why I have to fail so much. It was really a lonely place. But thank God I found this community, and the journey has been amazing so far. So our composting systems, as we all know, with the thermophilic compost, that is the soil food webs approach, that is on the photo to the left. And we also do vermi composting. These are vermiculture still at this stage because we only have these 4 bins where we use the red wiggler worms to do the composting of our feed material. So this is how it looks inside the bin. You can see the worms going through this feed material and they convert it into worm casting. Optimum conditions here need to be at around 60 to 70% moisture. So we keep it moist, and the water drains from the bottom of the tank. We have an outlet for water draining, and we collect that water as a vermi liquid, which can also be used to apply on the soil. So this would seem like a pretty small scale. And having 4 bins of worms, you would wonder, how far can this really go? So there is one way, I think. Sorry, I'm going to talk about the aerated compost tea that I learned to make. I took this initiative at the beginning of this year, especially because some of the larger tracts of land, it wouldn't really be practical to do it with compost, especially if you have not done so much compost. So we had to get a way of making a little go a long way. And that is when I decided to try. Let's give it a try. I've seen all these videos over the years, always putting this on the shelf, all these excuses, I don't know where to find a pump and stuff like that. But I took a leap of faith. Actually, there was a pump that we started with before what you can see here on the right, but that one didn't go for so long. And this pump, which is much bigger than what we started with, is actually an improvised one. I got this out of an old vacuum cleaner, managed to get this housing around it and to get this piping outlet. And this actually increased our capacity from what we used to do about 200 liters to 1,000 liters. So for 1,000 liters, we are able to cover a big area. So the amount of compost that we use or have been using on this tank is about 3 kilos of compost, and basically aerating the system and getting the microbes to multiply in the water, and then putting it out after 24 hours or 24 hours of brewing. So I'm going to change screens so that we can have a look at another video. Let's just take it back. Okay. Yeah, so basically that's it.
So that's your little Hoover pump. You took it out of a vacuum cleaner. You fabricated and connected it to that system that you've got there. You've got 3 kilos of vermicompost in there. that you are
Yes.
aerating and feeding. What are you feeding? How are you doing? What is it you're feeding in there?
So there is the Vermi Compost, and there is also some foods for the microbes, which we are going to have a look at once we get back to the other slides. We are going to have we are going to look at the bio amendments that we use as a feed for the microbes as you multiply in the tank.
Wonderful.
So basically that is the aeration process. We have our compost in those bags, just giving them a little massage. This had been a few hours of pumping. This was around 9 a.m. We started at 5, and you can see already how dark that liquid is. And it was absolutely smelling of mushrooms at that point. So I was thinking,
Wow.
well, I wish I could have a way of having a look at it. All right. So back to the PowerPoint. That was the aeration process. We saw the 3 kilos of compost. That depending on we were spraying on a crop that is already, that was the final spray that we were doing. So the crop is already quite big, the maize crop. So that covered around 7 acres with just about 900 liters of the aerated tea. But if we were doing it on a younger crop, that could stretch it, I would think, to about double that size, or maybe 15 to 20 acres on 3 kilos of compost.
Wow.
So some of the bio amendments, what we do is do a combination of a KNF technique, that is Korean natural farming, and we do our compost teas using the amendments. What we have on the left here is a fermented plant juice that is from the shooting buds of or young tips, growing tips of the plant. That is where you're going to get your good extract with the right hormones that you need for plant growth. All the extract is done by having a mix of brown sugar, or best to use is unprocessed sugar, what we call jaggery, or yeah, jaggery would be the best to use. We do a 50-50 mix based on the weight of the material and the weight of the sugar, and let it ferment in that jar for a few days. It will let out the liquid which you're going to filter out, and depending on the stage of development of the crop, the recipes will vary. Each input will each input will vary depending on one, what crop you're growing, and two, the stage of development. But we basically use all the implements or all the amendments at all stages. We have lactic acid bacteria. This is the bacteria is cultured in rice wash water, and then we add some milk. After the rice wash water is fermented, that is usually in a few days as well. After the milk, after collecting the milk serum, there will be a separation of the liquids and the solids. So after the separation of the solids from the fluid, which is the milk serum, we also do another mix of sugar. Again, based on volume, equal parts. That will give it a longer shelf life without refrigeration. We have here oriental herbal nutrients, one from ginger and the other one from garlic. This one I just started the other day. So the fluids are still, the fermentation is still taking place, the fluids are still separating, but still after this point, we will still have to use, for the extraction, we will use some alcohol, maybe some vodka. Let that also continue fermenting for some time and get the extract. The inclusion rates for this usually are very, very low. So the alcohol will not really hurt the microbes. I'm getting some feedback. Yeah, so this is important, maybe especially in the transition stages of getting this regenerative thing going, because sometimes you may get challenges that would make you feel like you want like you feel like to protect your investment, you need to apply maybe something like a fungicide. Instead of doing that, this is something that will work quite well. It is not going to hurt your beneficials, but rather the pathogens are the ones that is going to take care of. We have here a water-soluble calcium and phosphorus that is extracted from bone meal. This is done through boiling it in water. This also is one of the ingredients that we use in making the compost tea. And finally, this is fish amino acids. There is a mix of tilapia that is cut up, wood shavings, brown sugar, and top up with some water. And this is let to ferment over. This actually went for four months before we got this out. So yeah, this is a good source of amino acids for the plants, and also will feed your fungi populations in the compost tea, in the brewing process. So what are the things? Oh, these are now the application. The photo on the left is when you are doing the final application, that tea that you just saw the brewing. The photo on the right is on the earlier stages of the crop. Earlier stages of the crop. So some of you have seen this photo. It is one of demonstrations of actually how this tea can really be effective. We have a transformation here. You can see this is the same area, and you can see the kind of transformation that took place in just 4 days of application. The photo on the top, the plant is looking like a bit discolored, not growing quite well, but in 4 days time after application, there was some really significant change. We also had other issues. This is an area that had a problem with some serious compaction. And you can see how stressed out this crop is. Roots are struggling to go. They're struggling for nutrition, not growing very well. So what we did with this area is we came in with broad fork and loosened up a bit of the soil with the broad fork, and then did a generous application of compost tea. And these two photos are 2 weeks apart. I'm sure this transformation wouldn't have taken place without that kind of intervention. So basically just shows you how the microbes are effective at doing their work. We also noticed in the growing season that this year especially we've had some increased plant vigor. As you can see from these images, at 9 weeks of development, we were seeing tillers developing on the maize plant on quite a good number of stems, which was an indication of well-balanced and good nutrition. Basically, good conditions for growing. At this point, it was quite a bit dry. So for the plant to be looking this way, you know, we've had suppressed rains this season. So I think by the time we were taking these photos, we had had a few weeks without any rain. There is also a significant increased pest resistance. This here is an image of a leaf, a plant that had been attacked by fall armyworm. We had had that issue on a very small area of the crop. So we decided that let's see this out. Let us see how the plant is going to behave. If it seems like it's going to get out of hand, then maybe we may need to intervene. But after a few days, we noticed that the worm was no longer feeding. And in another couple of weeks, there were new shoots developing from the maize. And as you can see, the old leaf really took some serious bitings, but the new leaf right here is looking quite okay and quite healthy. And these crops right here, I went the other day to check what was happening around this area. They've developed very well and producing. So we didn't fall into the trap of trying to get to use a pesticide and let the crop just do its thing. And we, in the first season of using microbes, really, we are seeing good pest resistance. So this season, we are also seeing a lot of maize stalks putting out double and triple cobs that are actually filling out grain. Sometimes you see this happening, but you get the third cob not filling grain, or very small cobs. But at this stage of development, this size is quite okay, and all the cobs filling grain, and that is on the majority of the plantation. So this gives me a lot of confidence that this year's harvest is going to be much better than what we've had in the past, and at significantly reduced cost. We cannot even begin to compare the costs of doing it in this way versus a farmer who had to go and put out fertilizers, who had to go and fight pests with the pesticides and all those kind of things. So we are really looking forward to this year's harvest. So in conclusion, I just want to say that regenerative farming is the way to go. I have seen that it works, and not just on small scale. There's a potential to scale it without necessarily having to incur very huge costs. And also to remind us that as farmers, we bear an enormous responsibility. We need to be responsible about the kind of foods that we produce. We are going to feed people, we are feeding our animals. We need to be really concerned about the health, and we also need to be really concerned about the health of our environment. So let's keep on pushing, let's keep on taking the word out there. Let's get more people into regenerative agriculture, because that is the only way we are ever going to start discussing or talking about using or having discussion around using food as medicine, as John Kempford put it in his podcast. So that is it for my presentation. Thank you very much. So that'll be it.
Wow, wow, wow. Can everybody give, you can go down to your reaction button and give Paul a huge round of applause. Paul, that your story is amazing, from everything, from the fact that you are innovating around the machinery. You're not saying, okay, now I'm stuck, I can't do anything, these things are not available, whatever. I mean, your story reminds me where you've taken Hoover guts, the motor of a Hoover. In my 20 years ago, when I started my salad business, I took the motor of a sewing machine. Well, actually, I didn't do it. My brother did it. He took a motor of a sewing machine and the drum of a washing machine, fabricated those together to give me a spinner that I could spin and dry the lettuce in before we packed it. But that's what it takes. We need to start saying, how do we connect the dots? Many of these things have been designed, have been built. It's a matter of repurposing them for our needs. So very well done on that front.
Thank you.
One question to you. So you went from that small motor and the small system to now a much bigger system. You mentioned to us in our other WhatsApp groups that the commercial farmers in the area are now also looking at you and saying, what is it that you're doing and how can you teach them? And you were a bit worried because you were like, I don't know how to do these on a massive scale. Okay. So my question to you is, how far did that conversation go? And like I say, we do have Stuart Barden in the house who is doing things on a massive scale. And it's really great that maybe we could have a conversation right there about, you know, what were your fears? How did you respond to those farmers in your area? And maybe, Stuart, maybe you can help us bridge that conversation with Paul for him to understand it. Because like I say, we were on Stuart's farm today, where honestly, I believe in small scale because it's easy to manage. He's doing what we're talking about on a massive scale, and it's working, and it's amazing. So over to you to tell us about the conversations you had, and then maybe for Stuart to maybe give you a little bit of advice on how that conversation can go.
Okay. Yes, conversations are still ongoing. Only that now they started mid-season, so there's really not much we can do right now in terms of engagement. But we are talking to a few people looking to see how we can implement some of these things in the next season. And of course, for some of them, they are well aware right now that next season could begin as early as now, because we need to really put the microbes down and have them and protect them. So we cannot again start leaving soils bare, so that we need to start tilling them again next season. So that is the conversation that we are having with a few of them right now, that we need to start next season now. Immediately after we harvest, we need to take care of the cover. So we are having discussions around what cover crops, and if we are going to use cover crops, how then are we going to terminate the cover crops in order to put down now the cash crop. So that is what we are thinking about at the moment. The presentation, and as we concluded, now I would like to welcome anyone who wishes to ask a question. Please go ahead.
And I think that, Paul, thank you for that. I think that the way we will do this is, if you have a question, please raise your hand, and James will reach out to you. So raise your hand in the using your emoji, and James will reach out to you. I have one question I would just like to start with, Paul.
Yes.
You spoke about if you need fungal dominant compost.
Yes.
Liquid tea or compost tea.
Yes.
Why don't you just talk to us a little bit about that? Why would somebody want fungal dominant? How can you connect that to what we've been learning across the trophic levels? What does it mean? Because as we've learned things in isolated, this particular group, on some of the other groups as well, the biology class, they learned about the trophic groups. But what group requires fungal dominant, and why did you go for fungal dominant?
Now, having come from a conventional approach, we realize that our soils are highly bacterial dominant. And we all know, moving through the trophic levels of or even crop succession, we need to grow row crops, and in particular, in this case, the maize requires that we have at least a balanced bacterial to fungal ratio of 1:1. So in this case, a more balanced bacterial to fungal ratio, or leaning towards fungal dominance. So it was important for us to ensure that we are culturing and feeding the fungal to the fungus, to ensure that our teas are at least the more fungal dominant. That is what we really needed in the fields. Already with the early succession, we had already unbalanced soil, which was leaning towards a more bacterial dominance.
And just to make that connection, what is it that we know about bacterial dominant soil? What does that do?
Bacterial dominant soils will mostly support weeds. So if you're growing in soil that is highly disturbed, soil that is done with a lot of or with synthetic inputs, fertilizers, doing herbicides and doing pesticides, then you're basically setting succession backwards and favoring weed growth rather than your target crop.
Exactly. So what you've basically done and what you're showing us is now putting together everything that we've learned in class about those trophic levels and about that succession. If everyone for a minute can just picture in their minds that diagram that you kept seeing of the soil food web. You saw the first trophic level, the second trophic level, the third and the fourth. You learned about bacteria, you learned about fungi, you learned about protozoa, you learned about nematodes. Bacterial and fungi you learned about. You also learned that the succession, where we had the pictures with the little image on the top that showed us weeds to forests, just as Paul had said, where your soils are very, very bacterial dominant, that's where you're going to be getting your weeds. And grass is somewhere midway in that succession of plants between forests and weeds. Grass is in the middle there. It needs more nutrients from the soil, but it needs them converted into ammonia. And it is the fungi and the protozoa and those others in the trophic group of the microorganisms that convert the nitrates from the bacteria. They eat the bacteria. So they take up the nitrates. So the nitrates are not being produced for weeds. They're now consumed and in the other microbes' bodies. When they excrete or when they are eaten, what is released is ammonia. And that now is what the grasses and the other trophic levels need, the other successive plants need. And in your case, Paul, that's what you were doing, was converting your bacteria, converting your nitrates in the ground using microbes, not using chemicals, converting the nitrates in the ground that were there into ammonia for that maize.
Yes, so that is exactly that. In fact, synthetic fertilizers with their highly oxidizing effects would normally lead to more nitrates available. Actually, not quite good ammonia. So basically, when you're putting down fertilizers, you're feeding weeds rather than feeding your main crop. So that is why you would have to go back and now have to start fighting those weeds.
And then it's a big vicious cycle. So let's get on to questions there. James, do you have anyone with questions?
No, I have not seen any question on the chat. Anyone with a question, please? Alois Kenneth, please go ahead.
Okay, thank you, James. And thank you, Mr. Paul, for the wonderful presentation.
Thank you.
I only have some few questions here to raise. The first one is, how often do you apply the compost tea? And then the second question is, when you are now doing the extractions of the plant material after they have fermented, how long should it set for the compost tea to seed? How long will it take now to seed? And then the last question, how long it take to brew compost tea, or when the materials? Thank you.
Okay, now the compost tea is done over a 24-hour period. So basically, you brew for 24 hours, and trying to go beyond that has shown that some of your fungal or some of your fungus could, if and when you've multiplied really large numbers of microbes and they consume up the oxygen really fast in the water, then things could start going anaerobic. So 24 hours. Okay, to your next question. In our case, we did 5 applications. And the reason also why we had to do so many applications is because if you can remember, I shared in class that we started off really not quite on the right foot, and didn't have the soil ready. It wasn't inoculated. So we were basically starting from a soil that was really, really poor. And I would say I decided to go with the many applications just as a precautionary measure, just to make sure that we are not missing anything. There were a few patches that had compost laid down, and those areas did very, very well, exceptionally well. And the rest of the fields are okay. But where we had the soil already done with compost, we have the best produce. So going forward, I think the best thing to do is to ensure that the field is ready, protect whatever we've already invested in the field, have it covered over the off season using a cover plant or a cover crop for now. Terminate it as close as possible to the time that we will be doing the next crop, just to make sure that we are continually feeding the microbes and continuing to multiply them. And our soils should be in better condition in the next season. Now, there is that one question about the amendments that I did not quite understand. If you can come again, I don't know if I really understood what you're asking.
Oh, I think it was the last question. I was asking, how long does it take to brew compost? So when, for example, when you want to plant your maize with the compost tea, and then we know that for our area we plant maize for 2 seasons.
Mm-hmm.
So before I plant the maize, I should have been having the compost tea prepared early, so that when the maize grows, I spray it. So
Okay.
before the preparation of my land and all that, so the timeline for the planting and the compost and the compost tea preparation, how is the time there before the plantation and then before I make the compost tea? So how will I know that when I apply at the time I will be planting my crops, my compost could have been now, my compost tea could have been now ready to spray. So that time frame duration.
I get you. Now, the compost brews over a 24-hour period, and once it's ready, it has to be used up immediately. So if you want to use it for planting, or if you are going to spray in furrow as you plant, or if you're going to wait for your seedlings to come up, it is done over a 24-hour period of aeration, and then put out immediately. It is finished. It doesn't sit. You cannot store it. I hope that answers your question, Alois.
Yes, thank you. The very last question is,
yes.
When I'm collecting the extract, is there any natural way apart from the biological way I should use to get the extract? I make preparation, and then I make the compost tea. When the natural way apart from the biological way, can that one also be applied, and how?
Do you mean
something here?
Madam?
Paul, do you mind if I
Hello?
jump in quickly?
Yeah, please go ahead, Sue.
So Alois, the natural way and the biological way are the same thing, okay? What Paul is doing is he wants to make large volumes of compost tea, and he wants to breed up the microbes to push them in the direction of higher fungal dominance. Therefore, he's following a recipe. You cannot keep it. It's like putting milk outside in the sun. It will go bad. If you leave your compost tea for more than 24 hours, and that's now one that's being aerated with a machine, it will go bad. The same microbes that make maziwa lala, that make maziwa go bad, they will also affect your compost tea, and your compost tea will go bad. And when you put something that's anaerobic on your plants, on your crops, you're pushing them backwards. So here's the thing. You can use the way Paul is making it, in which case he's making large volumes, he's making 1,000 liters, and he's using a pump to keep the air in there as he's breeding the microbes. A quicker and simpler way for a smaller area is to say, okay, if I have an acre of maize and I planted it and it's germinated, and I want to put some compost tea on it, you can make the compost tea in a bucket, put 1 kilo of compost in a bag where the microbes can come out, wash it in 20 liters of water, wash another kilo in 20 liters of water, wash a third kilo, then you have compost tea there. But you need to use it within the next 1 or 2 hours or it will go bad because you're not aerating it and the microbes need oxygen, okay? And you put many there, but you're not feeding it. You're not brewing it. You're using what you stripped off from your compost material. Then you can take that and you can go and spray it on your plants. Is that clear?
Yes, okay. Thank you for that clarification.
Yeah. So there's no keeping compost tea. There's no keeping it. If you keep it and you've not aerated it, it will go bad in a couple of hours. If you keep it and you've aerated it and you keep it for more than 24 hours, it will go bad. You make it when you need it. You don't have it waiting ready for planting. You don't prepare it waiting ready for planting. You prepare it when you're going to use it. You use it that day or the next day, bas, and you use all of it, yeah?
Okay, thank you.
Okay.
Yeah, what you need to prepare in advance is your compost. That is so that when you want to make the compost tea, you'll be having compost to use. I think I'm right when I say that, Sue. Thank you so much. Thank you so much.
You're absolutely right. So remember that Paul is using vermiculture. Now there's compost, which you're making just with your materials like we're all making. And then there's the worm compost. They're two different things. The compost that you're making in the garden when you're making your big piles of 1 meter by 1 meter by 2 meters, that is thermophilic compost. It must go very hot to kill all the pathogens. And the microbes that start in there are the bacteria. You put 10% manure, 30% green material, 60% brown material. You've made your compost piles nicely. And the microbes have broken it down. You've kept it damp. You've kept turning it at the right times. You've registered it on iCow so we can remind you when to turn it. That will take about 20 to 40 days before you have compost. 1 ton of compost will reduce to almost half the size. You can take some kilos of that compost now to wash it in a bag that has holes so that the microbes can come out, to massage it slowly. And we'll do another video on that to show you. And you can use that so that you now get the microbes in a liquid. In the liquid, you can spray it over a much bigger area, but you don't want it sitting. You can do the same thing. The vermiculture, the one Paul is using, he's looking at using earthworms. Earthworms do the same thing as your compost, but they do it in cold temperatures. Not that your outside temperature is cold, it's that the home that you've designed for those earthworms cannot get hot, they will die. The earthworms are the end of the trophic, well, they're further up the trophic level, the macro arthropods and the earthworms. Those things don't like hot temperatures. The bacteria can withstand very high temperatures, so they can be in the thermophilic. But if you're doing earthworm composting, it is a cold process, which is why we say keep it shallow. You're not building a big 1 meter pile of earthworms. You're keeping it shallow, you're feeding them, and they're staying wet all the time. And it's a cold process. With the other compost, it's deep. It's 1 meter by 2 meters by 1 meter. The temperatures are rising. It's very hot. The temperatures are rising because of that microbial activity. And that activity in itself is doing that decomposition of those materials you put in there. You can use either of those, vermiculture or the compost that you're making when it's cold, to take the microbes off by massaging it and making a compost tea. Okay?
Yeah, thank you so much for that explanation. Let us now go to Eric Angote, please. I saw your hand up. Please ask your question.
I have 3 questions, but maybe to start with, one, there's this term compost tea. I'm a bit confused somewhere. I don't know if compost tea only applies to the thermal composting I've heard of, or also to the vermi, vermi composting also, something of the sort. So the byproduct that we get from the regular worms, that liquid, is it also compost tea? And then my other question is, when it comes to these regular worms, is it possible for me to determine the quality of the tea that will come out of it by maybe maintaining certain quality of products that I'll be feeding to the worms? And then on the other hand also, when it comes to the tea that comes out of the regular worms, how long does it stay before it expires? Or it will just exist there for a longer period as long as I'm ready to use it?
Okay. Am I taking those, Sue?
Yeah, go ahead, Paul.
Now, Eric, it doesn't matter what your compost material is, whether you are doing extracts from the thermophilic or you're doing from the worm or vermiculture. Both of those will still be compost tea or compost extracts. From my understanding, the teas are brewed. The extracts are the ones that you get by the massaging and all that. Now, again, feed material for your worms. It is always good to maintain diversity. The more diverse your feed material, probably the better quality you will have, or the better microbial diversity. You remember we are looking for microbial diversity. So more feed materials, sometimes these microbes enjoy something else more than this other stuff. So diversity is key. You're not necessarily looking for nutrients, although that will also be part of it, but diversity of microbes. So maintain also a diversity of feed material. And for your the leachate or the warm liquid, in my experience, I've had liquid that went anaerobic, but that had stayed about 14 days after extracting it. I think I sent a sample to Sue and she confirmed that it was actually going anaerobic. There was a lot of ciliate. I don't know if it had already gone, but it was throwing off. I think it can keep for a bit, but not so long. Maybe don't try to go beyond a couple of days, but it is best to put it out immediately you get it. So don't store it. But I've had some people suggest that you can do a mix of sugar, brown sugar or molasses, and it will keep gassing off. That should give it some shelf life. I have tried it before. I don't really know. We couldn't really check. I was just doing it and putting it out after some time. But I think it would be nice to try that and have it sampled. Maybe do it with molasses and then have it sampled after a couple of weeks. It would be able to tell us if it actually went anaerobic or not. So I guess that would be it.
I'd like to add to that, Paul. So, Eric, your question of those teas, are they all called compost teas? So Elaine Ingham teaches that a tea is like when you make chai, yeah? You don't just take your chai, put Maggi in there and then use the rangi straight away, yeah? You actually leave it to brew, yeah? You leave it for some time, otherwise you don't get the right and full flavor of your tea. When you're doing compost extract, you're washing it and you're just taking them away straight away. Elaine Ingham calls that the extract. The tea, she calls it when you're brewing now, you're multiplying microbes. When you're doing the extract, you're not multiplying them. It's like saying, I've got this material, I want to take what's the microbes off it. When you first have to actually extract before you actually then make the tea when you do the brewing. Because then in Paul's case, he's extracting and then he's brewing, he's adding feed and he's brewing. So two different processes. When you look at the a lot of people have been taught that to do vermiculture properly, or to do vermiculture, the worm juice, they are told they pour water on top of the worms and then collect water out of the bottom and assume that now is worm tea, worm compost tea, whatever name it could be given. But the reality is that stuff might come with some nutrients, but it doesn't normally come out with a lot of microbes. Remember this, the microbes produce a lot of glue. They want to stick where they are because they actually feed and move within a certain environment. They don't want it to rain and they get washed away. Remember, we learned about glomalin. We learned about how microbes actually create the structures in the soil, the gluey structures in the soil. That also helps them to stick there. So when you've got vermiculture that is just earthworms in their home and you pour water on it, that liquid that comes out the bottom is not necessarily going to have a good number of microbes in it. If you want to extract the microbes from the worm, the Vermi Compost, which is now the stuff the worms are living in, then you can either do it by massaging or extracting it first like Paul does, and then brewing it to feed those microbes and the fungal things. It might sound rather confusing. I hope it's not too confusing. But a tea is when you brew, and when you're brewing, in the case of what we're doing with microbes, you're trying to grow their population. And that's why it takes time, because they take time to multiply. It doesn't take that much time to take them off the material. You can massage it off, and then you have them in a liquid, and we're calling that the extract. Yeah? So that first extract, let's all stick with those words. The first extract, you can use it directly sprayed on your plants or on your soil or drench your soil. Or you can then take it and multiply the microbes further to produce more. But it's during that multiplication process that things can go anaerobic. The extraction process things will go anaerobic a little bit slower because you've not given them the food to multiply quickly. It's like saying, I invite everyone to my house, and no, that's difficult to say like that, because it's like saying we have a whole bunch of caterpillars and we can put the caterpillars in a box and they're just there, or we can put the caterpillars in a box and feed them, and or a creature in a box and feed it, and it multiplies to become more because you're feeding it. So when you're doing the vermiculture tea or the compost tea, as Paul is doing, brewing, you're feeding them. You're making them happy, you're making them multiply. But when you're doing the extract, you're not feeding them. You don't have to use any of those materials Paul is doing, but you won't get as high a concentration as microbes as Paul would be doing, because you're only taking out what is there in the material you had, but you're making it in a form that you can spread it further. That 1 kilo of compost, if you put it in your land, it might go in half a bed. But if you put it in 20 liters of water and take the same microbes out, you can now spray those microbes across 1 acre of land. Making sense?
Yeah, it is.
Okay, anyone else with a question?
One question, James. I feel like maybe I've not been understood, or I did not get it right. I was asking about the compost tea that comes out of hello, Samantha. The compost tea that comes out of I've been given the compost extract that comes out of the Vermi compost. That is for the worms, regular worms. How long is it supposed to stay in that collection bin when I'm collecting it while feeding the worms? Do I have to use it immediately? It drops into the container, or I can wait for some time and then I accumulate. Maybe I can give an example.
You shouldn't be getting anything.
Sorry?
Why are you getting a liquid coming into that bin? In which bin? Explain to us your system.
The ones I was given at Ilri, I came and then I placed them in a container. And then I've been feeding them. And there is some liquid that is dropping into a receiver container down. So that liquid, I've not used it. I'm assuming, well, at first I thought it was the compost tea, but I now understand it's an extract.
You know what it is? You know what it is? What is dripping down in the bottom there is basically the juice that is coming out of the materials that you've been feeding your worms. Have you been putting water?
Have I been doing what?
Have you been putting water?
Yeah. Just to make the content wet.
Okay.
Moist,
so ideally, you shouldn't be getting any liquid down there at the bottom. You shouldn't really be getting liquid at the bottom. That stuff that's coming out is not compost extract. It's not compost tea. It's not vermiculture extract or vermiculture tea. It is just what has been coming out from the breakdown, maybe of some of that plant material you've been feeding, maybe a little bit of nutrient that might have come through also when you've been adding water. In an ideal situation, that the liquid that's coming down, it's not what you're growing your worms for. Have I confused you now?
Now I'm totally confused.
Okay, let me let Paul, who is the vermi culture, the vermi compost expert here, explain to you what that liquid is and why it's there, and what the extract is and what the tea is. Only thinking about vermiculture, not thinking about thermophilic piles, okay?
Okay, so it is actually called warm liche, or whatever. And as Sue correctly pointed out, some of your materials will actually release the fluids that they hold. Some of that could eventually end up seeping out. That would be normal. And also, for maintaining your system, you also need to keep it at a certain moisture level. So if you're watering, then you will be able to also get some leachate. Now, the leachate could be loaded with some nutrients. And of course, you are extracting some is it fulvic acids, which are loaded with nutrients, but not a whole lot of microbes. So, but then what could also happen, Eric, is that if you have it sitting out there, then some other microbes could start breeding in the water. Remember, microbes also are present even in your surroundings. So other microbes could start also breeding in that water because it is loaded with nutrients. And as I told you, there was a time I had some of that leachate sitting out for about 2 weeks, and it started to throw off. And when it went under a microscope, there was a lot of ciliate activity. And I think some actinobacteria, which is an indication that things were heading towards the anaerobic. My experience with putting out the leachate on a crop, it was not very, very effective as a foliar application, but as a soil drench, it will work to provide your crop with some of those nutrients that is available in the leachate. But having said that, the reason why you're breeding or you're keeping your worms is eventually for the compost. So if you're going to do extracts from the compost, or you're going to do teas from the compost, then you will end up with more and better biology than if you are putting out the leachate. For now, maybe still early, you're getting some little bit of leachate. Use it kidogo kidogo, maybe in your kitchen garden or a small area, but it's not going to do a whole lot for you. You are going to get those benefits once you get to good numbers where you can do extracts or the teas. I hope that is better now, Eric.
Yeah, it's better now. Though, let me ask a last question for clarification, full clarification now. So I saw you have 4 bins.
Yes.
Now, those 4 bins, you're intending to multiply them to 8 bins.
Yes.
So what exactly are you using in those bins? Are you using the liquid that comes out of the worms, or you're using the soil, the compost that has been broken down by the worms?
I've never taken out any compost. I used to use the leachate. It turns out that it's not a whole lot of anything in terms of microbes, maybe some nutrients. So I would normally drench soil. There was a time I used to spray. But now that we can do compost teas and extracts, that is what I normally use it for. So I would do the tea or do the extract, and then I would still put the material back in the bin. So that material is not spent in the field. After the extracting, I put it, now I get the material from older bins, and when returning, I return to newer bins. So if I have the first two, that is where I usually get the compost that I use for the tea. After I've done with the stripping off the microbes, I put that material back in the newer bins, and hopefully they will recharge.
And when you're doing that, the worms are in those whatever extracts that you're coming up with.
Now, careful to pick out, not to pick out a whole lot of worms. Sometimes they will be there, but it is found that they will go through the process and they will survive it. Although sometimes you will find that they've actually been stripped of the contents of their guts. You will actually see through a worm. I've seen that, but it's still alive. But everything that was inside, it's actually become almost a see-through. So, but they survive the process. The little ones that find themselves in the bag. I think also maybe moving forward, what I need to do is to get a small screen where you can be screening out the worms from the compost. So put the worms back in the bin and proceed to use the compost on for the tea or the extract.
So you know the other way of doing this, Paul. The worms are just like any other of our livestock, right?
Mm-hmm.
What you can do is you can starve them. Not that we should be starving our livestock, but normally when you want to change a earthworm bed, what you do is you stop feeding altogether or only feed up on one side. If you're only feeding on one side, that's where all the worms will go. Then you can take out at least 50% of that entire bed and be guaranteed it will not have a lot of worms in it, because for the last 1 or 2 weeks, even more, keep feeding on one side. If you're feeding from the top and they're all over the place, that doesn't work. But when you want to shift them in the bed, you feed them on one side. They don't go to food and then go back to sleep on the other side. They stay where the food is. So they will eventually all move, and then you can use that stuff to inoculate new beds and also to use for your compost, for your vermiculture extracts and teas and brews.
Yeah, that's right, Sue. Thanks for that tip.
Let us know how it goes when you do it. I have another question for you. And this now is around the innovation part of it. You fabricated a pump using an old Hoover. How did that happen? Walk us through that. What was, what were you thinking, and what had you done before, and why an old Hoover?
Wow. I had actually been putting off attempting an aerated compost tea for quite a long time. On the notion that I simply could not get a pump. That is what I thought. And but in the turn of this year, I decided, let me see. Let me just walk around these hardwares and see what is available. So I got this pump that drives a spray gun, and I asked the vendor, can this run for 24 hours? He was like, well, let's try. We possibly could, and it did. It ran the first 24, ran the second 24. And the third time, until a point where now it could not take it anymore. And now we were back to where we started. I still need a pump. By that time, I'd actually done some work for someone, and it was giving me a problem because now the pump would keep stalling. That's when I started thinking about this vacuum cleaner, an old one that has been sitting at home for a very long time. And I was thinking, this thing sucks in air, and where does that air go after it's been sucked in? It has to be let out somehow. So I decided to strip it, and I saw the pump, and I saw all these vents with so much air. I ran it, and it was blowing a lot of air. So I thought if I could just harness this air and let it out through a small pipe, then I'm good to go. And a vacuum pump will run and run. It will not blow. So basically that was it.
Wow. So that is the thing, isn't it? Is being curious, not only about the biology we're using or the plants we're seeing it effective on or the other things, but also around what do we have around us? What technology or possibilities do we have around us that can help us make these things, that can make things be even easier and more effective? Well done on that. That's really.
Thank you.
I was making salad pack